Hello class, this is the video for section 2.4 and the topic is a library of functions, piecewise defined functions. Okay, these are our learning objectives. Grab the functions listed in the library of functions. In fact, this is a review because we look at some of the functions in section 2.5 last week. There are about 2 or 3 more I'm going to add. And so we're going to put all together and we'll call them key functions, or if you like, you can call them basic functions. And then we analyze a piecewise defined function. We define it and then take example, graph it, and then do an application. All right. So these are some of the key functions. The first, which we didn't talk about in 2.5 last week, was a constant function. Okay, so the constant function is that f of x is equal to b for every x, which is a real number, and that's a straight line which is parallel to the x-axis. Okay, and the second one we want to call is what the identity function. In fact, this function is the same as the y is equal to x. Okay, the slope is 1, and so it passes to the origin and it's positive. Okay. The third is the square function, which is a parabola we talked about last time, last week. The next one is a cubic function. So if you have f of x equal to s cubed, the graph is that. Okay. And we have the square root function. All right, the square root function, and then it's got the square root function, and the domain is from 0 to positive infinity, and then the range is also from 0 to positive infinity inclusive in both cases. Okay, in fact, we'll talk about we'll pick about 3 of them, talk about their properties, okay? And then the next one, which we did talk about last week, is the cube root function. And this is the graph for that, okay? And these are all key functions. And then we also talked about the reciprocal function, okay? It's a rational function, but specifically we call it a reciprocal function. And this is this is its graph, okay? And then the absolute value function, which we also did talk about last week, okay? Now, the other new one that we haven't talked about is what we call the greatest integer function, okay? Now here, the f of x is defined as the int, which means the greatest integer of x. What does it mean? It means that the greatest integer less than or equal to x. So I just put some table here for you to be able to explain what is happening in this graph, okay? So for example, if you look at this point here, okay, x is between -2 and then and -1, but it doesn't include in -1. Now, within this interval, okay, within this interval, the y value is the greatest value, the greatest integer that is equal to or less than what? Okay, so if I pick x is my -2. Now, within that interval, what is the greatest integer that is less than, okay, less than or equal to -2, and that is -2. Why? Because -1 is not part of the interval. That is why there are parentheses there, and so the y value is it is -2. Therefore, the point is -2, -2. Okay, now for the same interval, if my x is say -1.5, -1.5. Okay, remember it's an integer. -1.5 is not an integer. So the y value is the greatest integer less than or equal to what? -1.5. And then within this interval, -2, it is less than, is the integer that is less than or equal to -1.5. That is why the y value is also -2. And therefore the point x is -1.5, and then y value is -2. Now, if you pick this interval that is between 0 and 1, okay, between 0 and 1, if you pick a s is 0, within this interval with the same explanation gives me the corresponding y value, which is 0, and that's the origin. And then if you keep going, let's go to the last one for the interval x between positive 4 and then 5, but positive 4 is inclusive. If x is positive 4, y is the greatest integer that is less than or equal to what? 4. And that value is what? It's 4, because the 5 doesn't include. It's not part of that interval. Okay, so this one is going to be what? 4, 4. That interval is 4, 4. Now, how do we get this into the graph? For example, if you take the first interval here, and then within that, we know that when x is 2, okay, x is negative 2, y is negative 2. So that's why there's what? This is close at what? Negative 2, 2. Now, every interval, every value, x value within that, it's the same what? S value. That's why it is what? It's a constant function there. But when it gets to negative 1, okay, when it gets to negative 1, it jumps to what? Negative 4, negative 1 for the y value. Okay, so this function, greatest integer function, also sometimes called the what? The step what? The step function. Okay, because it behaves like what? Like a step. Now, one application for this is with cell phone companies, right? And if this is what units or minutes that you use, okay, if you use, in this case, if you use like a 1 minute, they can charge you $0 or they can charge you $1. Now, if you use 2 minutes, okay, if you use 2 minutes on your cell phone, the company can charge you $1 or what? $2. If this percent what? The dollars they charge. Okay, so these are basic key functions that we want to introduce. All right, now let's look at some properties of these functions that we did look at in both 2.5 and this section. So we have the what? The square root what? The square root function. What are the properties of that? Let's bring the graph. This is the square root function. Okay, what's the domain? Domain and the range is what? The non-negative what? Rare numbers. In other words, it is what? The domain for the domain and the range for this function is what? It's from, that is, sorry, 0 to what? Positive what? Positive infinity. Okay, it's a set of the non-negative rare what? Rare numbers. That is 0 is part of it. Okay, now what is the x and y intercept? The x intercept is what? The origin. The y intercept is also the origin. Okay, now if you look at this function, it is not even nor odd. Okay, it's not even or odd. I will show you for this, but for the others we will look at, I will not show. Now your y is equal to, also your f of x is equal to square root of what? X. Now to test that it is even, just a review, you plug in negative x, and so what is negative x of that? Okay, this is an imaginary number. You cannot have negative under the square root. Okay, so this is not equal to what? It is not equal to say negative of x, okay, or nor is it equal to what? The square root of x, which in this case will be minus f of negative x, and here will be f of what? X. If it is this will be odd. If it were this one, then that will be what? Even. So this function here, if we stop there, we can't do anything. It's not a real number. So that is why it is neither what? Even nor odd. Okay, it's an increasing function. As you are moving from left to right, it increases from 0 to what? Into infinity. All right, over this what? Over the domain. And then what is there? Does it have an absolute minimum? Yes, this value here is what? Is absolute minimum at x equal to what? 0, and the minimum value is what? It is 1. Sorry, 0. Okay, now let's look at another function. Let's look at the cube root function. The cube root function. What's the domain? There's a cube root function. Domain is what? All real numbers. Okay, so the domain is what? All real numbers from negative infinity to positive infinity. And what are the x and y intercept? Okay, the x and y intercepts are the origin. both of them. And then is it odd or even? Yes, this is what? This is odd, because with the same explanation, if you plug in negative x, you get a cube root of what? Negative x, and this is equal to negative of what? Cube root of what? Negative x. Cube root of x, and that is what? Minus f of what? X. And therefore, this is what? This is odd. Okay, so if it is odd, we know that it was symmetric with respect to the what? The origin. And then it's an increasing function on the interval on its domain. Okay, does it have local maximum, local minimum? Okay, we cannot tell. It doesn't have no local, no local maximum or minimum values. Okay, next is the absolute value function. What's the domain? Let's bring up its graph so that you can see. Okay, what's the domain? Domain is all real numbers. You cut across. Okay, all real numbers. Okay, that's your domain. What's the range? Okay, the range is starts from 0. So the range is what? Includes what? 0 to what? Positive what? Infinity in the interval notation format. Okay, what is the x and y intercept? Well, this value here, okay, the origin is both what? X and y what? Intercepts. Okay, this is symmetric with respect to the y-axis. So that's an even function, and it's symmetric with respect to the y-axis. And then it's what? Is it increasing or decreasing? Well, it decreases, okay, as you from what? Negative infinity to 0, and then increases from 0 to what? Positive infinity. So that is why we have this portion. Now this value here, it is what? Absolute what? Absolute minimum. So absolute minimum value is 0 at what? X equal to 0. All right, so now let's define a piecewise defined function. Okay, now sometimes a function is defined using different equations on different parts of its what? Its domain. And when that happens, that's what we call what? The piecewise defined what? Defined function. Okay, piecewise defined function. Now, the simplest example we can give is what? The absolute value. The absolute value is, this is the definition, by definition is equal to what? X if x is negative, and is what? It is negative x if it is what? Greater than or equal to. Actually, this is rather negative and this is positive, sorry. Okay, so this is negative when it's that. For example, absolute value of what? Negative what? Say 2. Okay, this is equal to minus of minus 2, because it's what? Negative x, and that is why this is what? This is 2. Then if you have my absolute value of say 2, if you use this part, it's just what? It's just x, and that is what? That is what? That is 2. Okay, so this definition is what? Minus for the top one and then positive for the what? The second one. Okay, now let's take other examples. Now this is a piecewise function. We want to find the function values at what? 0, 1, and 2. We want to find its domain. We want to locate if there is any what? The intercepts, x and y intercept. We want to graph it, and then want to use the graph to find what? Find the range. So we want to do this individually. This is a piecewise function. As you can see, this is what? This part is what? Is a linear function. So that's a line. That second part is also a line. It defined for the domain, the first one when x is what? Less than 1, and the second when x is greater than or equal to what? Equal to 1. So that's a piecewise function. Now let's find f of 0, f of 1, f of what? F of 2. Okay, now with what? What is f of 0? F of 0, which of these functions? Is the top or the bottom? F of 0 includes, is part of what? It is part of this domain. Because x is less than what? Is 0 is in that domain. Therefore, we use the top part. So for this, we're going to use f of x is equal to negative 2x plus what? 3. So f of 0 is equal to minus 2 times 0 plus 3. And that is equal to what? Equal to 3. So with the coordinates will be 0, what? 0, 3. Okay. Now, what is f of 1 and f of 2? We'll do it the next slide. Okay. F of 1, okay, notice that f of 1 is part of what? This domain. So we use the second one. So f of 1 we're going to use 3x minus 2. So let's evaluate when x is equal to what? 1. So that's 3 times 1 minus 2, which will give us 3 minus 2, which is what? Which is 1. Okay, the coordinates will be 1, 1. Now, what about f of 2? Again, f of 2 belongs to what? This same what? This part of the function. So we use that. So it'll be 3 times 2 minus 2, which will give us 6 minus 2, that is 4. And then what are the coordinates? This will be 2 and 4. Okay, so now you evaluate the function. This is part A. Now part B is that we should find the domain. Now domain, I want us to focus here. Okay, we have what? If you write in an interval notation, you have what? From negative infinity to 1. Okay, and the union, this is what? It inclusive 1 to what? Positive infinity. Okay, so if you have this, this will result into what? All of them, because for this part, it doesn't include what? 1, but in that part, it includes 1. Therefore, the domain will be from what? From negative infinity to positive infinity. In other words, all real numbers. Okay, so that's the domain of this what? This piecewise function. Okay, now let's find the y-intercept. Now for y-intercept, don't forget for y-intercept, okay, y-intercept, we set x to what? X to 0. Now x is 0 when that belongs to what? This part of the domain. Okay, it's for when x is less than what? X less than 1. And so therefore we use the top part. Okay, so if you want to find x and we set x equal to 0, as we did, we're using that. That would be what? Minus 2x. That's the one we have to use. We have to use f of x equal to that. So therefore, f of 0 is what? Is equal to 3. So x-intercept, sorry, y-intercept is what? 0, 3. Okay, so what is the finding? Want to find the what they call x-intercept. Sometimes we can find them, they don't exist, depending on the domain. Okay, the answer you get. Now, are there x-intercepts? Okay, when x-intercept, what we do is that for intercept, we set what? We set y equal to what? 0. We set y equal to 0. Okay, so first, let's consider f of x equal to 0 or y equal to 0 when x is less than what? 1. So we pick the top part, which will give us what? Minus 2x plus what? 3 equal to what? Because y equals that, and solve. Okay, we have what? 2x is equal to negative 3. And then we have x is equal to minus 3 over negative 2. And this will give me what? Positive 1.5. Okay, now 1.5 is not in this domain. Okay, 1.5 is actually greater than what? 1. Okay, so that means that we discard this what? You discard. Okay, you discard. It is not the x value that we got. Okay, for this function we use is suppose we had x is less than the value here is less than what? 1, then we can say that it is a x-intercept. On the other hand, when you have x is greater than or equal to that, let's check and see. We use the second function, the bottom one. So that is 3x minus 2, y is equal to 0. So let's solve for that. We have 3x is equal to what? Minus 2, that's positive 2. Okay, and then we divide both sides by what? 3. So x is equal to 2 over what? 3. Actually, this is less than what? It's less than 1. Again, you do what? You discard this value of x for that domain. Therefore, what's your conclusion? There is no what? No x-intercept. Let me erase that. Okay, there's no x-intercept. Okay, no, or just say none. All right, okay, we'll see that in the graph in a minute. So we have x-intercept, we have none. Y-intercept is what? The point 0, 3. Okay, this is the y-intercept. This is your y-intercept. Okay, so now let's go to graph this. Now we want to pick each of them and graph. Pick the f of s is equal to, so you just say for x is less than 1, we know that f of s is equal to minus 2x plus what? 3. Or you can just say that this is a y is equal to minus 2x plus what? 3. So we want to graph this. Okay, we know this. We just need 2 points. So what I will do is that I will use, even though it says that it doesn't include, I'm going to use s is equal to 1 and see what happens, knowing that for the first, this part of this function, this part of the function, the x equal to 1 doesn't include. Okay, it's not part of the domain. So when I draw the graph, there will be a hole in that in that place. Okay, so what we do is that let's pick two points on this graph. Just need 2 points. Okay, you need 2 points. All right, so for 2 points, we can do x, okay, and then y. Now, when x is equal to 0, we know that this is equal to 3. So the point is what? The point is what? 0, 3. Then I can pick s equal to 1 because I want to see, just need anything there. So s is equal to 1. You have what? You have negative 2 plus 3, which is also 1. So I have this point 1, 1. Then I have to do it for the other part. Okay, for x greater than equal to 1. Now my y is the second one, 3x minus 2. Then I also do for 2 points. Okay, I'll do for 2 points for that. So I'll be x and y, and that's the next is my point, x comma y. Okay, so it doesn't have a y-intercept. Okay, so I'm going to use 1 and then the number 2. That belongs to this. Okay, that belongs to that. So when x is 1, we have what? 3 times 1 minus 2, which is 1. So the point is 1, 1. And then you have 2, s is 2. We evaluated from part A. This is equal to what? Is equal to 4. So this is 2, 4. Otherwise, or you can do it 3 times 2 minus 2, which is before. Okay, so we have these 4 points. Okay, so we can draw a graph here. We have 1 and 2. 1, 2, 3, 4. 1, 2, 3. Okay. All right. So let's plot these points. For the first one, the x-intercept is what? We have 0, 3. Okay, 0, 3, which is this part. Okay. 0, 3 is that. And then we have what? 1, 1. Okay, 1, 1 is here. 1, 1 is there. Okay, but there is a hole there. So we can draw this graph. This would be a straight line. Okay, and then goes up like that. Okay, but there's a hole there. I'm going to change the color to draw the other one. For the other one, it has 1, 1. When x is 1, is part of the domain. So this point, we're going to what? Close it. All right. And then we have 2, 4. 2, 4 is here. Okay. And so we draw this point. Okay. That's the line. All right. So this goes up. This is for y is equal to 3x minus 2. And this graph is y is equal to negative 2x plus what? Plus 3. Okay, so from this, what is the domain of this function? Okay, what's the range? As you can see, it includes 1 and goes up. And therefore, it starts from what? The range is from 1 to what? Positive infinity. Okay, so you can see, we didn't have what? Intercept for, x-intercept. So that's why this graph doesn't go all the way and doesn't cross the x-axis at all. Okay, now, let's pick an application, all right? It's a cost of electricity. Okay, in the spring of 2005, Salt River Project supplied electricity to residents in Arizona at a charge of, I want us to know that, at a charge of what, $20, okay, plus 11.48 cents per kilowatt hour for the first, what, 700 kilowatt hour supply in the month, and 11.60 cents per kilowatt per hour for all usage over what? Over 700 kilowatts in that month. So what it means that any time for the, what is the first part, they charge you, okay, 20 cents plus this, they multiply it by, let's say this is X. Now where X is what? The first part where X is what? Less or equal to 700, okay? And a 0, it can't go to negative. They charge you $20 plus what? 11.48 cents times every usage between what? 0 and then what? And 700. Okay, less or equal to. And then in addition to that, if you use more than 700, let's say if you use 800, then the extra after 700 was 100. They will multiply it by what? This and add it to the charge between less or equal to what? 700 kilowatts per hour. Okay, so let's look at the following. Said, what is the charge for using 500 watt kilowatt hour in a month? So if I use, what will be, how much will be my bill? What will be your bill if you do this? Well, because 500 is less than 700, the charge will be what? Okay, the charge is what? $20 plus this. Now you have to convert it to what? To, excuse me, that's a cent. So to a dollar, it is what? 0.1148. Okay, so that is, your charge will be $20 plus this times the 500 watt kilowatt hour of the electricity you used. So when you multiply this out 20 times that, your charge will be what? 77.40 cents. Okay, so that's part A. Part B, it says that, what is the charge for using 1,900 kilowatt hour in a month? What will be your charge? Okay, now remember, there's a charge, special charge, there's a charge for when you use between 700 and what? And 0. Okay, and then also we have what? Greater than, sorry, just what? X is, if your X is your usage, time greater than 700. Okay, so we're going to do this and say that if it is 1,900, your charge is what? According to the question, is $20 plus this, okay, for the first 700 kilowatt hour, then plus 11.60 cents per watt. Kilowatt hour for the next, what exceeds what? 700, because 1,900 minus 700 is equal to what? 1,200. So this part, whatever the standard you have between, for the first 700, they will multiply it by what? 1,200 and charge you. Okay, so what happened is that is, your charge will be what? $20, which the question says, plus 0.1148 times 700, then plus the extra, which is what? 0.1160. If you convert it to a dollar, that is 0.1160. Then times 1,900 minus what? Minus 700. So that is what? 1,002. So you plug it in, and then you multiply. This is how much you'll be charged what? For the month. Okay, so then let's go to the last part of the question. It said that if C is the monthly charge for X kilowatt hour, develop a model relating the monthly charge and kilowatt hours used. Okay, that is, express C as a function of what? As a function of X. Okay, so well, we're going to throw in X now. So let X represent the number of kilowatt hours used. Okay, now there are two parts. Remember, if you use what, between 0 and 700, then your monthly charge is given by what? The $20 plus 700 times that. Okay, but we're going to call that X. All right, so how do we express that? So for X, if X is between this, it's going to, your C of X is what? It's 0.1148 times X plus what? Plus 20. Okay, so what is the charge when it exceeds? That is when X is what? Greater than what? 700. Okay, it's going to be this one. Then we add what? 0.1160 times that what? X's, which will be the X minus what? 700. Okay, so that gives us the second part, which is that you have 0.1148 times 700 plus 20, then plus 0.1160 times X minus what? Minus 700. Since this one equals the usage in excess of what? 700 kilowatt hour. So this will cost how much? If you put it together, you have this expression. So you have 0.11, okay, 48 times 700 plus 20, then plus 0.1160 times X minus 700. So when you simplify this, okay, if you simplify this, this is going to give us what? This will be the expression for that. Okay, so you remove the parentheses, multiply this by X, and multiply this by what? 700, and then add, combine like terms, you get this. So then this gives us what? A piecewise function. Your domain, see that's the usage, okay, the power you use when it is what? Between less than or equal to 700. And then when it's greater than 700, this will be the function. And so this electricity company, to charge you, the bill that is sent you for this particular case, this is the function they will use. Okay, if you use 700, this is the function they use. If you use more than 700, that's the function they use. Okay, and so that brings us to the end of what? This. But we can put this in the graph. It says that the rule for computing C follows two equations. Okay, as we have talked about. So note that the two pieces are both linear, but they have different slopes, or what they call the rate at which they charge you, and meet at the point what? They meet at this point 700. So that means when if the Z is 700, that's when they meet. So they meet at this point, but they have different slopes. So if you draw both together, like we did for the example we did, we can put this together and then get what? Get this graph. Okay, so that actually brings us to the end of this section, and we'll do more examples in class. And thank you.